I think
Just change it by like one digit. That must be
I think you guys are you guys will be ready for it.
That's like a no.
That's a guess. All right, guys. So this is your time, right? So just ask questions. Anything you have in mind? Anything from the past exams, from homework, from past finals, anything. So I'm here for you guys. Standard form, yeah. Do you have a particular problem, or do you wanna?
I mean, I saw a bunch on like finals. So
Is it one on
from
the
there?
finals that I gave you, or no?
Yeah, I'll
You have one?
Yeah, we do a bunch of.
Okay. So 4A. This is what? This is fall. 17. Number 4. Number 4 has.
Like rip it out.
So part A says what? Express in standard form and find vertex. So it asks you to do two things at once. Find the standard form, and once you have the standard form, then you can find the vertex, the coordinates, right? So what's standard form again? You have to recall, what's standard form? What's the standard form of a quadratic function? Does anybody remember? These are past exams. This is the 2 past exams from last semester, which is not on Blackboard. Ooh, yeah, so see, you guys have the inside scoop. That's why you come here and you get rewarded with some more stuff.
You get extra credit also.
This is extra credit.
We can get one skip on the test.
So what's the standard form?
I know how it looks like.
What does it look like?
Parentheses x plus a
So it's x minus h
yeah.
squared. There's an a in front
minus
plus
yeah.
k. This is the standard form of a quadratic equation. And then what are the coordinates of the vertex? You can read it off right out, h comma k. So once I get it in this form, I can just read off the vertex, right? So the question is, how do I do that with this here?
So I
You know this, okay? What do you do?
cube root.
The cube root.
Yeah. No.
No, you do not take the cube root.
Could you make it 2 parentheses and make it x and x?
So the first thing I want to do is I want to factor out whatever's in front of the x squared. I want to factor that out. And what's in front of the x squared? Negative. So I'm going to factor out the negative 1 like this. And when I factor out the negative from the negative x squared, it becomes positive x squared. If I take out, and what I'm going to do is I'm going to factor out the negative 1 only from these first 2 terms. Remember this constant term? We kind of just like forget about it for a moment and we just leave it on the outside. So I'm going to take out this negative. So take the negative from x squared. Now take the negative from positive 4x and it becomes minus 4x, right? And I'm going to put some space. I'm going to put some extra space here. So I'm going to do something here. I'm going to add by 5. So all I really did was move the 5, the constant term, as much as I could to the right. And I factored out whatever's in front of the x squared. I factored that out from these first 2 terms.
Over 2.
Right. What do? You complete. I'm going to complete the square. Remember how you complete the square? This is a very important technique, algebraic technique. You take this number in the middle, in front of x. You divide it by 2, which is what? 4 divided by 2 is 2. Then you square it. Right? That's the whole step. But then, what are we going to do? We're going to add by 2 squared and also subtract by 2 squared, right? Why do we do that? It cancels out. We're not changing the very function. We're just changing the way it looks. So we're adding by 0 in a very clever way. We're adding by this number and subtracting by the same number. But then why do we do that? Why does it work out? what's the very nature of completing the square? Now that I completed the square, what is this guy here?
X minus 2 squared.
Perfect. It's a perfect square trinomial. That's what happens after you complete the square. You create a perfect square trinomial. And why is that good? Because I know how to factor this whole thing. And this becomes, so this negative is still out here. This becomes x minus 2 squared. And what's left here? A minus 4 parentheses plus 5. So remember, be careful with the parentheses. This guy has a set of parentheses because I factored it, but I still have the parentheses around it here. So we're almost, this almost looks like this, because I have this squared here, right? But now I want to complete the form. So what do I do now?
You add 5. Do you have 1?
Remember, I only want one set of parentheses. I have how many here?
You distribute it.
So I distribute that, the negative 1 to this guy, and then I can distribute it to this guy. And then what am I left with? I'm left with negative parentheses, x minus 2 squared, negative times negative is a positive, 4 plus 5. So I'm almost there. The last thing I need to do is combine 4 and 5, and this becomes negative parentheses, x minus 2 squared plus 9. Right? Because all I did was I combined constants. And now look what I have. Don't I have what A is? What's A? A is in front of the parentheses, which is negative 1. What's H here? 2. And what's K? So then what's the vertex? 2, 9. Boom, done. So this is my final answer. And this is my final answer for the standard form. So that's how to go from a quadratic. This is a quadratic function, right? It's a standard form. And finding the vertex, yeah.
So does it matter the sign in front of the numbers or no?
What do you mean?
Because there's negative 2, so does the vertex.
So there's x minus 2, right? This is x minus 2, right? And this has to equal what? X minus h?
Yeah.
But then when the x's, when you subtract the x's, right, you get h. If this is a plus 2, h would be negative 2. So remember this whole thing here, you just flip the sign. But this sign, whatever this is, it's exactly what it is.
You know, like you can find the vertex of the calculator too if you graph it. Just get the highest point.
Excellent. Right. You can find the vertex by finding the maximum and minimum. Right? But you don't need to. Why? Because you guys are experts.
I think that's good in
algebra.
chapter.
And you just can do the algebra. And then boom. Magic. Algebra is the magic portion of mathematics. Okay. Anything else from this question?
I have another question.
You have another question?
I have.
Great. Thank you for the question.
So like here, I don't know how to do this, and this pops up.
Yeah. Okay. Yeah, this pops up, I think, in every single one.
Yeah, it does.
And usually it's like the first question. So don't be surprised if the first question on the final will include something. That's what I'm going to show you. And they tend to use the same kind of function again and again. So here we go. This is spring 2017. This is question number 1. Question number 1 is if you see the final exams, they tend to be very similar. And we have a function, f of x, and this is our reciprocal function, our reciprocal parent function, 1 over x, right? We've seen this, we know what it looks like. And the question that was asked is part G, which says if h does not equal 0, compute the following. Compute f of a plus h minus f of a over h. Now, what is this called? This is the difference quotient. The reason why we do this to you guys here in this course is that when you take calculus, you're going to be doing this for the first, probably the whole, first half of the semester is going to be all about this. Okay, so let's begin. What's the first thing we have to do is evaluate each of these functions. So what's f of a?
1 over a.
1 over a. All you have to do is replace the input with the input that you have. So f of a equals 1 over a. I just replaced the x with the a. That's all I did. And now what's f of a plus h?
1 over a plus h.
1 over a plus h, right? All I did was I replaced wherever the input is, I replaced it with the input that I have received. Great. So now I know f of a is 1 over a. I know f of a plus h is 1 over a plus h. Now I'm going to use this formula. I'm going to plug this guy in here. So what was f of a plus h? It was this expression. So now I'm going to place that right there. So this would be 1 over a plus h minus what? F of a. So what's f of a? 1 over a. So I'm going to replace that with 1 over a. Now I'm going to divide this whole thing by h. That's how I begin with this. Now, of course, I'm not going to leave it like this. I want to simplify this, right? Now, what's the issue with this? How do I simplify?
Make the common
Common denominator. And what is the common denominator?
A plus a times a plus h.
Right. That's it. So the LCD of this guy here is a times a plus h. In other words, we're just trying to make the denominators the same, and we're going to multiply by the top and bottom by anything that's missing from the other side, right? So remember, a plus h is distinct from a. They're two different things, because this plus makes this a completely different term. So what's missing from a? A plus h. So I'm going to multiply here, a plus h, and on the bottom here, a plus h. What's missing from this guy here? The a. So I'll multiply this by a and this by a. That's what I'm going to do. I'm going to multiply a over a, and I'll multiply this by a plus h over a plus h. And this is just an algebraic concept that you need to have clear in your head. How to add fractions with unlike denominators. You need the LCD, or the least common denominator. So then you multiply the fractions across, right? A times 1 is a. And what I'm going to do here, I'm just going to multiply a with a plus h. I'm not going to actually distribute it yet. I'm just going to put them together. And then I'm going to have this as a plus h over a times a plus h all over h. So what I did from this step to this step was to create the same like denominators. And why do I create the like denominators? Yeah, because now I can combine the numerators and keep the denominator the same. So I have a plus h, right? I can create now one single fraction in the numerator and have this h on the bottom. Now be very careful here. This is where people get points off. You're subtracting a minus the whole expression a plus h. So a lot of people, what they tend to do is just subtract a minus a and leave it as positive h. But really what happens when you have this negative here? You distribute it, and then what do you get? You get a minus h over a plus h over h. And then what happens with the a minus a? Cancels out, and I'm left with what on the top? A minus h, not a positive h. Okay, wow. It's a lot of fractions here. I have a fraction on top divided by h, but h can be written as what kind of fraction? H over what? 1. So really what you have is a fraction divided by fraction. How do you divide by a fraction? Multiply by the reciprocal. And what's the reciprocal of h over 1? 1 over h. So I'm going to put this over here. So then what happens? I get the negative h over a plus h multiplied by 1 over h. Because I flipped, right? I multiply by the reciprocal. And what's the nice thing that happens here? You cancel the h's because the h is not 0. So I can do this. No problem, this becomes a 1. No problem, this becomes a 1. And what's my final answer? Negative 1 over. This is my difference quotient. So this is f of a plus h minus f of a over h. It's this guy here. So my final answer is negative 1 over a times a plus h. That's my difference quotient. This is a very common problem. I think we've seen this in the previous one in 2018. I think they also have something like this. I think they have 3 over x.
Yeah.
Right? Yeah, they have 3 over x. It's very similar. I'm pretty sure the final answer will have a negative 3 maybe. Something like that. But anyways, these are the steps for that.
Do you get partial credit?
Did I get partial credit on the exams?
No, but they're doing it.
Huh?
But aren't they wrote it, so.
So they wrote it and I have to grade it. Yeah, I wish it was like that. But it's not. I'll grade it too. Yes.
I have a question from this final answer.
Okay.
B number 3.
Because before we go there, is there any questions about this? Okay, because this will be on it. I have a high, confidence that this f of a plus h minus f of a over h difference quotient will be on it. So which one is it? What number is it?
3B.
Number 3. Part B. Okay. And what's the question?
Secant of sine inverse
Secant of sine inverse
radical 3.
radical 3 over 2?
Yeah.
Oh, you got this.
No, I
Huh? So we've done a lot of these, right? In the past few weeks, we've done a lot of trig, especially inverse trig. Okay, so how do we do this? Nice thing is, it's kind of a simple. Whenever you see sine inverse, what do we always think of?
Angle.
Angle. And what is that angle usually? 60. Well, in this case, it is 60. This is theta, right? So I like writing like this because it's just sometimes easier to understand this. So square root of the inverse sine of radical 3 over 2 is equal to some angle theta, right? Some angle theta. And I can rewrite this the same thing as saying sine of some angle equals radical 3 over 2. Now, what is this angle that gives you radical 3 over 2? 60. So theta can be written as 60 degrees or what? Pi over 3 radians, right? So make sure you're able to go back and forth with radians and degrees. So essentially, we just found what the inside of this function is. Sine inverse of radical 3 over 2 is 60 degrees. Well, let's deal with radians. It's actually radians. So it's secant of pi over 3. It's okay if you do 60 degrees, but make sure you become more comfortable with radians because you're going to be using radians much more than degrees, especially in calculus. You're not going to be doing degrees. Okay. So now you're here. Secant of pi over 3 radians. But what's secant?
1 over cosine.
1 over cosine. Right? This is cosine and secants are reciprocal, not inverses. They're reciprocals of one another. So secant is 1 over whatever cosine would be evaluated at this point. But what's cosine of pi over 3? Or what's cosine of 60 degrees? A half. So you got 1 divided by a half. And what's 1 divided by a half? That's why I told you should be at the beach, memorizing sine of what angle gives you radical 3 over 2. Radical 2 over 2. You gotta know these. It's gotta click.
How do you memorize it? How do you memorize
I did 1, 2, 3. So what do you do? Cosine, cosine, or reverse?
Okay, I think there's a little trick.
Can you put us onto the trick?
I think. Hold on, let me see if I remember the trick. We have theta, right? And we have what? What was it? Is it like 0? This is 30, right? 45, 60, 90. And I think this is 0 over 4, 1 over 4, 2 over 4, 3 over 4, and 4 over 4. And you take the square root. Now we take the 0 divided by 4 is what? 0, square root of 0 is 0, right? So sine of 0 is 0, we know that. What's the square root of 1 over 4? Sine of 30 degrees is 1/2. What's the square root? What's the square root of 2? Square root of 2. What's the square root of 4? 2. Sine of 45 degrees is radical over 2. What's the square root of 3? Square root of 3. What's the square root of 4? 2. Square root of 3 over 2. Square root of 4 over 4 is 1. Square root of 4, square root of 1 is 1.
This only works for sine.
But then there's another trick, right? Remember sine and cosine, aren't they kind of related? So these here go this way, right? Cosine will go in the reverse order. Do 1, radical 3 over 2, radical 2 over 2, 1/2, 0. Voila.
I just usually remember like the test. I just remembered 1, 2, 3. Like 1, 2, 3.
So then that's the way I would start. The angles here, you should know these angles. 0, 30, 45, 60, 90, right? We see these all the time. Sine of the angle, you put 0, 1, 2, 3, 4, and you divide all of them by 4. Take the square root, and you get these. What is cosine? Cosine is just the same thing, but in reverse order. And this would be.
So will this help with the question like 3a, just tan 3 pi over 4. So you add it.
Tan of 3 pi over 4.
Mhm.
Oh. You see, you can't rely on tricks all the time. You gotta know the so what is part A?
Yeah.
So remember how we always evaluate this? You can use your calculators, right? But how do you evaluate it without a calculator?
Sine, cosine.
You can use sine and cosine. Right, you can call this sine of 3 pi over 4. And this is cosine of 3 pi over 4, right? But what's sine of 3 pi over 4? So first of all, you have to know where, well, yeah, in a way you do. You can convert it, but you don't need to. Because you should know radians. What's 3 pi over 4? Where is that? Where am I in the quadrant? Second quadrant, right? This is going to be 0. This is pi over 2. This is pi, right? And what am I doing to pi? I'm dividing it into 4 equal parts. This is pi over 4. This is 2 pi over 4, which is pi over 2. This is 3 pi over 4. So I am in the second quadrant. Is sine positive or negative in my second quadrant? Positive. And what's my reference angle if my angle is 3 pi over 4? Pi over 4, right? This is my angle here. And my reference angle is this guy right here. This is my reference angle. Pi over 4. So I can write this guy here as positive sine of pi over 4. Hey, and what's pi over 4? Right, this is pi over 4, right? This is pi over 6. This is pi over 3. Pi over 4 for sine is radical 2 over 2. How about cosine? What's cosine in the second quadrant? It's going to be negative, right? I'm going to have a negative cosine. And what's my reference angle for 3 pi over 4? It's also going to be pi over 4. But what's cosine of pi over 4? It's also radical 2 over 2. Remember, it's 45 degrees. But wait a minute. What's radical 2 over 2 divided by itself? Anything divided by itself equals 1. So you have this negative here. So the answer will be negative 1. Done. So if you know sine and cosine, you know tangent. Because tangent is just sine over cosine.
You do it almost like the equation of a circle, which was
Yeah. Do you have?
I do.
I'm pretty much all the time.
Equation of a circle? Find the
Yeah.
equation of a circle,
Or
or
like a bunch of them, like stuff like the
They're on the old ones, but they're on the new ones. Actually, here.
this is fall 6, 2016. So, any questions about this?
So if we go home and memorize it, why find?
So one thing is memorizing it, and second thing is how to use it, right? Because you can go crazy and memorize everything. You have to know how to bring what you know and how to apply it. You have to know how to apply it regardless, right? How do I apply it? I need to first figure out where theta is. Then I need to know whether sine and cosine are positive or negative. And I need to find out the reference angle. See, these things you can't memorize, you have to know how to apply it. And then after you know how to apply it, then you can use your memorization skills and then apply it and then plug it in. Okay? All right. So this is fall 2016. Number 2. You have 2 points. -3, 8. And you have b, which is 7, 2. And then it says, it's a 2-part question. It asks you to find an equation of the perpendicular bisector. So find equation of perpendicular bisector. It's very geometric terminology here. Perpendicular bisector of AB. That's part A, right? And then we'll do part B. So from here, what would you do to understand this problem a little better? I'll try it. You can just do the sketch, right? What would be the sketch? Well, I know where A is. It's -3, 8. So -3 is going to be 1, 2, 3 is -3, and 8. 1, 2, 3, 4, 5, 6, 7, 8. And I do this little thing here, a little thing here. This is my point. This is A. So I know where A is on the Cartesian plane. And now I need to figure out where B is. Well, B is 7, 2. So 7, 2 is 1, 2, 3, 4, 5, 6, 7. This is 2 right here. And then this would be this point here. This is B. And what's the line segment, A to B? It's just a line that connects A to B. That's my line segment AB. Connect A to B. Now, what do I want to find? I want to find the equation of its perpendicular bisector. So what does this terminology mean? First of all, what does perpendicular mean? Right, it forms a 90-degree angle. So there's many lines that you can draw here that when you intersect create a 90-degree angle, right? So there's a lot of lines that are perpendicular, but I want a particular line that's what? A bisector. So not only do I want it to cross at 90-degree angles, I want it to cut it in half. So then how do I do that? What's the first step? I should find where the midpoint, the halfway mark. What's the midpoint formula? This is like day 1 of precalculus. This is day 1, right? Didn't we talk about the midpoint all that long ago? How do you find the midpoint between 2 points? You've seen this in Math 115 for a fact.
Find the slope divided by 2.
Just dividing by 2, but there's no slope in the formula. It's similar. It's a similar formula. It's really x1 plus x2 divided by 2. You add the x coordinates, divide by 2, and then you add the y coordinates, divide by 2. This is just finding the average of the x coordinates and the average of the y coordinates. You find those 2 things, and you find the midpoint. So that's pretty straightforward. Because I have my x1 and my x2, so I'm gonna call this my x1, y1. I'm gonna call this my x2, y2, right? I'm gonna use the formula. So what's x1 here? -3. What's x2 here? 7. What do? Divide by 2. y1, 8. y2, 2. Divide by 2. Negative 3 plus 7 is 4 over 2. 8 plus 2 is 10 over 2. Then this becomes 2 comma 5. This is my midpoint. 2 comma 5, somewhere here. This is my midpoint here. So this is important because now I know for a fact my line has to go through this point. But how does it have to go through? In a perpendicular fashion. And what do we know about lines that are perpendicular to each other and their slopes? What's negative?
The slope of the other one.
So perpendicular lines have what kind of slopes? Very important, guys. Remember this term? Negative reciprocal slopes, right? Right? This is huge. This is a huge piece of information. This is Math 115, really. This question is a Math 115 question, really. So this is like the review of Math 115 in the beginning of the semester. So how do you find the perpendicular bisector of a line segment? First, you find the midpoint. Boom, got it. Secondly, you have to find it to figure out what's the slope of this line. Because then I want to find the slope of this line. But because it's perpendicular, whatever slope this guy is, it has to be the negative reciprocal of the slope of this guy. So let me find the slope of AB. I'm pretty sure everyone knows how to find slope, right? So change in y over the change in x, which is y2 minus y1 over x2 minus x1. What's y2? 2. What's y1? 8. What's x2? 7. Minus x1, which is negative 3. So make sure you put the negative or positive. This equals what? 2 minus 8 is negative 6 over 7 minus negative 3 is 7 plus 3, which is 10. So and this reduces to negative 3/5. So what's the slope of AB? Negative 3/5. So what's the slope of the line that's perpendicular? It has to be the negative reciprocal. What's the negative reciprocal? It's reciprocal and it's positive. Or the negative of negative, which is a positive. So for a fact, what do I know? The slope of this line that I have to draw that's perpendicular has to have 5/3 as a slope. And it has to go through the point 2 comma 5. So this question is quite a compound question. It's asking you, do you know how to find the midpoint? Yes, I do. Do I know how to find the slope? Yes, I do. Then I need to apply those two things together. How do I get the line knowing the slope and the point? Remember, I want to get this. Y equals mx plus b. What do I know? I know m. What am I missing here? B. How do I get b?
You take one of the coordinates, the midpoint, and pop it to
That's the only one I have. So I plug in this point here. This is my x. This is my y. This will be what? 5 equals 5/3, comma 2 plus b. Now I have to solve for b. So how do you multiply this? 5/3 times 2 is what? So 10. How do you get b?
divide.
I can divide. I gotta get b by itself. I have this plus here. So how do you solve for b? Subtract. So then, what does b equal? b equals 5 minus 10 over 3. How do you subtract fractions? Common denominators, but the denominators are different. So what I need to do is multiply this by 3, and I get what? 15 over 3 minus 10 over 3. What does that equal? So my slope and my y-intercept are both 5/3. So what's the final answer? So what's the equation of a perpendicular bisector? It's going to be y equals what? 5/3 x plus 5/3. Done. This is my answer. This question is really a 115 question, math 115 question, because you're putting a whole bunch of stuff together. Do you know how to find the midpoint? Yes, I do. Do you know how to find the slope? Yes, I do. Do you know how to find the equation of a line knowing a slope and a point? Yes, I do. You're doing that all at once for one question, one part of a question. Makes sense? Yeah.
The negative reciprocal, you just flip it basically. and take
So
away
what
the
does it mean to be the reciprocal? Flip.
Just
That's what reciprocal is. But
So-
it's the negative of it.
right.
What's the negative of a negative? Positive.
So let's
Switch the
say
sign.
it was 3, 5. If you go to 5, right? I mean,
Negative
five
5/3. Yeah. So negative reciprocal just means change the sign, whatever that is. It's negative, positive, it's positive, negative, and then you just flip. That's what it means. That's you do this when you have perpendicular lines. Wait, before we go on, let me just complete this. There's a part B to it, and this is with circles, right? Okay, so it says find an equation of the circle that has points A and B as endpoints of a diameter. Now, what does that mean?
Can you reread the question?
Find an equation of the circle that has points A and B as endpoints of a diameter.
Okay.
So geometrically,
So,
what does that mean? Diameter implies what?
circle.
Circle, right? So I want this to be a circle, right? I want to create a circle from these 2 points, and it has to be the diameter. So what's the midpoint going to be?
2, 3.
It's going to be the center. This will be the center of the circle. Now, do you guys remember the equation of a circle? So this is part B. I have the information that I need for the midpoint. So I want to find equation of circle. What's the equation of a circle? X minus h squared plus y minus k squared equals r squared. And what's h comma k? It's the center. And what's my radius? R. Now what was the remark we made? Well, the midpoint is the center of the circle, whose diameter is AB. Makes sense? So I know what? I know H, I know K. So I can replace this with 2. This is 5. But if I replace the H and the K with 2 and 5, then I'm going to replace this H with 2. I'm going to replace this K with 5. So look, I almost have the equation of a circle. What's missing? R. So really the crux of the problem is, do you know how to find the distance between 2 points? This is a very good question. Why is it a good question? Because it tests you on midpoint, slope, perpendicular lines, find the equation of a line, and find the equation of a circle, all at once. A lot. So how do you find the distance between 2 points? You use the distance formula. So you see all these this formulas you need to know? And again, this thing comes from Math 115, not 122 really. This is review from Math 115. So the distance here, but you need to know this regardless. The distance here is what? What's the distance formula? Anyway.
The square root of x2 minus x1 squared plus y2 minus y1 squared.
It's really the Pythagorean theorem. This is really the Pythagorean theorem. Because between any 2 points, you can create a right triangle find the change in y, find the change in x, and then you have a right triangle, and the distance is what you're trying to find, which is the hypotenuse of the right triangle. Great. So then what do I need to use? I need to use my center as one point, and I can use either A as my other point or B as my other point. So let's use the center, and let's use B. So the coordinates of the center is 2, 5. The coordinates of this guy is -3, 8. So now I want to do what? I want to find the difference between the x coordinates. It doesn't really matter the order at this point, it doesn't really matter, but x2, what do you want to call x2 and x1? Which one?
It's already labeled.
Well, one of them is labeled, the other one is not. So this is a new set, it's like a new set. So this, I'm gonna call this like this, I'm gonna call this x1, y2, y1. I'm gonna call this x2, y2. This is a new equation, a new part of the question. So x2 is -3 minus x1 is 2 squared plus y2 is 8, y1 is 5 squared. So -3 minus 2 is -5 squared plus 3 minus 5 is 3 squared. So this becomes 25 plus 9. Take the square root. 25 plus 9 is 36. Square root 6. So what did I just find? I found that the distance between what? The center and the endpoint is 6. So if I found the distance between the midpoint, the center, and the endpoint is 6, then I found what? I found the radius. That's exactly what the radius means. It means the distance between the center and a point on the outside of on the circle itself. So R is, D is R. This equals R. So now I can plug this in here. Plug this in here. 6 squared is 36. So this is my final answer. So any questions about this? Like I said, you gotta be ready. This may or may not be on it. If it is on it, you should have no problem. I got it. Right? That's the shit. Anything else? Yeah.
Final question 6B. I don't know how to solve that. I'm not qualifying 6. 27.
My laptop's gonna die. So this will be cut. Yeah. Okay. Spring 2017, right? 6B. Just close the door.
It's plugged back here too.
Huh?
It's plugged back here too.
Yeah, but I don't know if it's okay. Yeah, actually, it's a better view on the board. So this is spring 2017, number 6, part B, right? What's the question?
1 over 1 minus cosine x minus
1 over 1 minus cosine x
yeah minus
minus
1 over 1 plus cosine
Yep.
x is equal to 2 cotangent x cosecant.
Cotangent x cosecant?
Yeah.
Whoa. Whoa.
I could figure it out.
Couldn't figure it out, huh? So we did something like this, but we didn't sign anything. I think in class we did 1 over 1 minus sign and 1 over 1 plus sign. This is cosine. Okay, so we want to prove this, right? I'm assuming. I want to prove this identity. So what are we supposed to try to do? Try to show that the left-hand side equals the right-hand side, or the right-hand side equals the left-hand side by some algebraic manipulation, right? Which one is the more complicated one, or which one requires more simplification than the other? Left, right? So let's look at the left. Let's go with the left. So left-hand side is 1 over 1 minus cosine x minus 1 over 1 plus cosine x. So then, the question becomes what? How do you combine two fractions with different denominators? You make the denominators the same. They're different. So then what do? You include the one that you're missing. 1 minus cosine x is distinct from 1 plus cosine x. So what's missing from here? 1 plus cosine x, right? So multiply the top and bottom by that very term. And what's missing from 1 plus cosine x that this one has? 1 minus cosine x. So all I'm doing is I'm simplifying, subtracting two fractions. I am trying to create one single fraction. Okay. When you multiply, you just multiply across. And for now, I'm just going to multiply and leave them as factors being multiplied. I'm not going to actually multiply it out yet. I'm going to see if I need to do it or if I don't need to do it. And then here, I'm going to have minus 1 minus cosine x over 1 plus cosine x, 1 minus cosine x. So far, all I've been doing is taking care of the left-hand side, simplifying it. For simplify two fractions, I have the denominators the same. So I multiply each fraction by the respective factor that's missing from the denominator. Great. Now I have two fractions with the same denominator. So I can keep the whole denominator, the whole fraction in one single denominator. 1 plus cosine x times 1 minus cosine x. That's my denominator. But I need to now subtract numerators. And so here again, please be very careful. It's 1 plus cosine x minus what? The parentheses 1 minus cosine x, because it's the whole thing that I'm subtracting. Not just the 1. It's the whole entire term. Two terms. Now let's do what? To get rid of the parentheses. Distribute that negative sign. And what do I get is I get 1 plus cosine x minus 1 plus cosine x all over 1 plus cosine x 1 minus cosine x. Right? So far, all I'm doing is step by step by step. Now, what can I cancel from the numerator? The 1 minus 1. This goes away. And then what's cosine x plus cosine x? Oh, so 2 popped out. Good sign. That's a good sign. But what hasn't popped out? The cotangent or the cosecant. So, but what do I have here? I have 1 plus cosine x, 1 minus cosine x. So then I should what? There's still going to be a sine square that's going to be involved, right? So how do I simplify 1 plus cosine x times 1 minus cosine x? I have to FOIL it. This becomes what? 1. This becomes minus cosine x. This is plus cosine x, right? And then finally this is minus cosine squared x. But the cosine plus cosine here cancel, right? And I'm left with 1 minus cosine squared x. So when I multiply this out here in the denominator, I get 2 cosine x over 1 minus cosine squared x. But then it's still, this is not as pretty as I would like it to be. I wanted to see some cotangent here or some cosecant here. But then you have to remember what identity? You have to know what? Cosine squared, right? Cosine squared x plus sine squared x equals 1. And from here, what can I say? Sine squared x equals 1 minus cosine squared x, right? So if I see 1 minus cosine squared, I can replace that with sine squared. Now, this is very compact. You see what we did? We went from this two fractions, broke it down, simplified, condensed it, and now look, it's quite compact now. Now, how in the world do I get cotangent and cosecant from this?
Well, isn't tangent sine over cosine, so it's tangent sine cosine.
That's exactly right. How many sines do I have here?
2.
Being multiplied to one another, right? So I can write this as 2 cosine x, right? Over sine x, sine x. But what's cosine over sine? Cotangent. It's a reciprocal tangent. And then what's 1? You can think of it as a 1 here. What's 1 over sine? So left hand side equals the right hand side, done.
How did you get to 2 when you
I added cosine x plus cosine x. How many cosine x do I have? Probably the hardest part of this is to, when you get to this point here, like what do you do after this? Like you kind of have to be guided by what you're trying to be led to, right? This is my goal. I'm trying to go from left hand to right hand side. So I'm trying to see how do I get to here? And I realize, you know what, this is not going to work for me. What if I multiply everything else? Oh, this works because now I can replace it with sine squared. Oh, and then this, see? I see the cotangent here and I see the cosecant here. But at the end of the day, you're using algebra the whole time. It's algebra. Not with trig. So any questions about this?
Will there be one with trig in it?
Huh?
Will there be one type with trig in it, I guess?
What do you mean? One with trig.
Will
This
there
is trig.
be
This is trig.
there's 3
No. For proving, it's just strictly algebraic. It's not gonna make you compute anything. So any questions, guys? Which ones?
Real world application.
Real world applications of what? Like number 9?
Like only this. Actually, it's like only more like these ones like squared.
What year is this? 2016? So it's some year in 2016, right? Sometimes 2016. I mean, it's not too difficult. Okay, this is more of the a lot of geometry for this one. There's a lot of geometry involved. This is sometime, I think 2016, right? You have an open box. So this is important. You have an open box with square base. Surface area, the surface area is 400 meters squared. Express volume as a function of x and x is the length of a side of square base. Okay. So what would be the first thing you think of doing? Remember, I think I gave you the guidelines to word problems and all that. What's the first thing you have to do? Before you draw. Read. You have to read everything carefully. Okay, that's a given, but people tend not to do that. That's why I say number one, read it. Okay, what do we read? There's an open box with square base. Number one, important information here. Let's see if we can figure out what's an open box. What does that mean?
A box with one side missing.
What's exactly? So see, and what kind of base does it have?
Square.
We know about squares, right? So then let's see if we can use our best artistic ability to draw a square to kind of, give it a little depth, right? 3D depth here. So then we know that these are what? Right angles, aren't they? What else do we know about squares? All sides, right? And what's one of the lengths of the sides? X. So we know this is going to be X. We know this is going to be X. This will be X. This will be X. You see how much information we get from one piece of information? One sentence. I haven't even completed it yet because this is the base and it's squared. But we want it to be in an open box. And we're going to connect this, right? This is what a box looks like, right? We know what boxes look like.
How would you think to draw like
That's the only way.
that? I would never get that.
No? You want to draw a box this way?
No, I'm just saying, not the way you drew the box, just like, I don't get why the problem is saying that's what it looks
It's a box, right? You know what boxes are.
like.
Yeah.
Doesn't it say with
Open.
an open box?
Yeah, so it's kind of hard to see. I can't draw an open box. I'm not that good. But you can imagine, right? You can imagine that this is on top of a table somehow, right? And like you are just so happy that you got your, what are you guys excited for? An iPhone, right? You have, oh, it's an iPhone, just, I ordered it online. And it's just like, wow, and you take out the top cover, boom, it's out. What do you have left? These faces of the box, which are 4 of them, right? And you have a face. So this guy here on top, I'm happy. Okay, good. Now, what do I know? That's the only thing I have so far. Check. Now, what else do I know? Very, very important. Surface area. Surface area. If you like surface area. How do you find the surface area? You're like, yeah, how do you find it? Well, how do you find the area of a square? On the side. How do you find the area? Length times width. But the length in here, the length and the width of a square are both the same. So you're multiplying x times x and you get. So the area of this square box is x squared. Now what you're gonna have to visualize is, let's say I wanna take this box and I wanna find the square area, right? I wanna find the area. So what if I cut this, the corners here, right? The edges, and I flatten it. I flatten the box, so I want to recycle. So what happens? Well, then I get something like this. I want to flatten it because I'm trying to be a good citizen of the world and recycle stuff, right? Cardboard. So I know this is going to be x, I know this is x, I know this is x, I know this is x, right? I know these lengths are x. So the area here has to be what? My area here has to be x squared, correct? Now what's one dimension that I don't know? Height. So what are we going to say? Yeah. these edges will be H, 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 H. So then what's going to be the area of this? Now this is not a square, it's a rectangle. What's this area here? Then how many do I have? 4 of them, right? What's confusing?
Why are those rectangles?
These rectangles come from this guy. So remember, think of having a box, you just opened it, you got the iPhone, great, you're happy. You want to recycle the cardboard, right? You're not going to do it like this.
When you
normally
flatten
you
the
would-
box,
you-
that's square.
You would flatten it, right? And one way to flatten it maybe is to just open the edge, like open these spaces. Like what if you flatten this guy? Flatten it. Like you're flattening outwards. I wish I had a box to show you. You're just taking this space here and you're placing it downward. So like think of having the box here, but a bird's eye view of it. And then I push one of the flaps down. Push the other one down, down, down. Now how would we get something like this? So maybe try it when you get home. If you have a box, see if you can flatten it and see if you get the same.
Would have been more than fun.
Yeah, you know what? But this is what happens visually, right? When you do that, you get something like this, and then you can find the area of each of these guys. So what's the surface area going to be? It's x squared plus what? How many of these do I have? 4xh, right? Equals what? 400. And what am I trying to find? Volume. What's the volume of this of a box? You guys know? Length times width times height. This is like. When do you guys learn this? Well, when should you have learned this? This is like middle school, you know?
It's too much trig right now.
Well, this is geometry. This is geometry. But what's my length here? X. What's my width here? X. So I can write this as what? X squared, right? Times my height. But what's the problem with this?
Always
It has to be terms of x only. I only want it in terms of x. I don't want it in terms of h. What's the very nice thing? I have an equation where I can find h in terms of x. So I want to solve for h, which means that what? I want to get h by itself. And how do I get h by itself? Well, before I do that, I need to get the x squared on the other side first. So I subtract by x squared on both sides. And what happens? I get 4xh equals 400 minus x squared, right? I want to get h by itself now. Now I have to divide. And I'm left with h equals 400 minus x squared over 4x. And then what does h equal? This whole guy here, right? It's in terms of x though. Now I can plug this h back in here, and what do I get? I get x squared times what's h? 400 minus x squared over 4x. And then what can I cancel out here? One x here with 1x here. So what's the final answer? V is x multiplied by 400 minus x squared all over. Any questions about this here? more questions? It's very long.
It's not a variable.
So that's why you have 2 hours and 30 minutes. You can use all that time.
I have a question.
Okay.
This one.
Mhm.
Can I write on this one?
Sure. Like little notes. Well, no, I'm going to take it back. If you need, you can take a picture of which one? 10.
Which one will be?
This is a makeup final from last semester. Yeah. So this is 2018, right? This is fall 2018. Now this is probably a little better for you guys. This is a little crazy. I understand it because this is something that you see more in calculus actually, but they're trying to get you prepared for calculus. So this is something that maybe it's up our alley. Right? A little better. And so this is solve the equation and find x or the angle, right? In interval. So solve for x in interval 0 to 2 pi. So I want to find all the x values that satisfy this equation from 0 to 2 pi. Great. So we have an equation here, and I want to solve it. Now, normally, what do we try to do with these type of equations? We try to make all of them the same kind, either sine. Also, all of them have to be sine, or all of them have to be cosine. So here, what should I replace what with?
Turn on 1 plus sine x.
So remember, cosine squared x plus sine squared x equals 1, right? What can I get from here? I can get that sine squared equals 1 minus cosine squared, and I can get that cosine squared equals 1 minus sine squared, can't I? Right, I would want to replace cosine squared with 1 minus sine squared because now I have everything in terms of sine. So 1 plus sine x equals 2 times 1 minus sine squared x. So I can replace the cosine squared x with something in terms of sine. Now I have an equation with everything has sine in it. So now I can replace it. I can distribute the 2, and I get 2 minus 2 sine squared x. And this is 1 plus sine x. Now, normally when we solve equations, what do we tend to do? We set it equal to what? 0. I want to set this equal to 0. So then how do I do that? So I put everything on this side. So if I add the 2 sine squared, and I subtract the 2. So this cancels here, and I'm left with 0 on the right side. And then what do I have here? I have a 2 sine squared x. I have a plus sine x. And 1 minus 2 is? Now, call it y. Yeah, I mean, the reason why I do that is because we already have x. So we'll use another variable. So I'm going to say let y equal sine of x. Now when I do that, I get 2y squared plus y minus 1 equals 0. And this is what? A quadratic, isn't it? Do we know how to solve quadratics? Yeah. What's the first way to try to solve a quadratic? We see if we can do what? Factor. Can we factor it? How do we try to see if we can factor it?
You do the first 2 terms and then
You multiply 2 and negative 1 and you get negative 2. And then you ask yourself, what 2 numbers multiply by negative 2 but add to positive 1?
1.
You need positive 2 and negative 1. Positive 2 minus 1, positive 1. 2 times negative 1, negative 2. Then I know that this can be written as 2y squared, right? Then I have what? Plus 2y minus y minus 1 equals 0. So I replace the middle term with those two numbers. 2 minus 1 is positive 1, and 2 times negative 1 is negative 2. Then what do I do here?
Separate. Two different equations, so do two.
No, not two different equations. This is one single equation. But what do I do here? Factor by grouping. I factor by grouping. So after I separated it, the middle term, two terms, and 4 terms, so I factor by grouping. And then how can I factor this first group here? What can I factor from this first group? 2y. Take 2y, what's left? Y plus 1. And what can I factor from here? Negative 1, and I get y plus 1 equals 0. And then what do I have in common? So I can factor out the now look what I just did. I factored the quadratic equation. Now how do I solve it? Take each of these factors, set it equal to 0. Solve for y, so y equals what? Negative 1, and y equals 0 what? Right? So I did math 115 here. What's 122? Y was originally what? Sin x equals negative 1, and what does sin x equal here? So I have two equations I have to take care of now. Sin x of negative 1. So how do you get what x equals? So what's sine inverse of negative 1? Pi. Pi. Remember? Unit circle? Remember what sine represents? The y coordinate, right? When is the y coordinate negative 1? Right? But what's this angle here? This is 0, this is pi over 2. 3 pi. So x equals 3 pi over 2. If you put this in your calculator, it will give you negative pi over 2. But you want the angle to be where? Between 0 and 2 pi. So negative pi over 2 would not be in that range, so you're going to have to add by 2 pi. This would be 3 pi over 2. That's why I would recommend, the best way is to understand the unit circle. It's all about the unit circle. So we took care of, yeah,
If you were to put sine inverse of
you get negative pi over 2. But your calculator doesn't give you pi over 2.
like it would actually give you pi, or it would give you like some decimal. Usually it does that.
So if it's in radians, it will give you a decimal.
But I wouldn't tell you pi. I know.
Yeah.
So
So then put it in degrees. And what would it give? It will give you negative 90 degrees. But I want it to be, first I want it to be in radians. And secondly, I want it to be between the interval 0 to 2 pi. So if I'm in negative pi, or negative 90 degrees, I have to add it by 360 to get 270 degrees, and then convert that to radians. Or, what I would do is understand the unit circle. This is better, I don't need calculator. I know it's 3 pi over 2. Certain of it. So does everybody understand that? How do you get x? I don't know. Another one. We have another one right here. So how do you find what angle gives you 1/2? It's the same thing, right? X equals what? Sine inverse of 1/2. But see, the problem with this is that your calculator doesn't give you pi, right? So you have to know what angle gives you 1/2. That's when you need to know the table. 30 degrees or pi over 6, right? So we know for a fact x is pi over 6. Correct? But is this the only angle? It's not. Why not? Second quadrant, because sine is positive in quadrant 1 and quadrant 2. So then if I'm in the circle again, I have 1 here, right? Pi over 6. I know sine is positive here, but sine is also positive here. So I know there's another angle that what? That has the same reference angle, pi over 6, right? But I want to find this angle here. So how do I figure out what this angle is here? And this is pi. Subtract pi minus pi over 6, and you get what? So then what's my answer here? What's my final answer? X can be what? Pi over 6? 5 pi over 6? And? So how many solutions do I have to this equation within the interval 0 to 2 pi? I only have 3.
Question on the yellow, Marno. Third question,
A?
A and C.
So it says solve the equations algebraically. So I don't want to use the calculator, I want you to solve it. So e to the ln of x equals 3. I want to solve for x. Remember e and ln of x, what kind of relationship is e to the x and ln of x? They're both what? They're inverses of one another. So what happens when you apply the inverse to its function to its inverse? Cancels out. So e to the ln of x is x. It's a property, remember? X equals 3, done. Move on. That's it, part A. Should be quick. Remember, e to the ln of x equals x. Why? Because f of f inverse of x equals x. And similarly, ln of e to the x is x. Because they're inverses of one another. If you apply one to the other, it cancels out. So that's quick. That's a quick one. So you said part C. Part C is 4 to the x minus 5 plus 14 equals 30. I want to solve for x here. So the problem here is what? X is what? X1. This is an exponential equation. What's the first thing I always want to try to do? Isolate the variable. So the first thing I could do is do what? Subtract 14. So if I subtract 14, I get what? 4 to some power, x minus 5, equals 30 minus 14 is? So now I have it.
So now
You can, but there's an easy way.
it's make the 16 to 4
Right.
or
4 what? 4 to 1 power gives me 16. 4 squared.
Yeah.
Now this is ideal. When you can't do this, you use logs. If you, I'll do the log version. I'll do this way. This way is easier because now look, I have 4 raised to some power equals 4 raised to the second power. So if the bases are the same, then you just say that the exponents must be the same. So look how nice this is now. Can you solve this equation? That's it. X equals 7, right? That's easy. But let's say you didn't see that. Let's say you're like, I'm so pressed with time, I'm so stressed. So then you're like, I know logs work 100%, right? Okay, so let's do it. So then I'm right here. I don't know this. I don't see this, even though this is much easier. Like this problem is a piece of cake. So like, I don't know how to do that. I didn't see it. What I do know, what do I do know? I can get this guy here on the bottom by using log. So either use log base 10, log base 80, which one would you like? So you use just regular log. Right? Log of this guy, you take log, right, on both sides. Now, you know a property of log is that you take the exponent and you put it in front. So this really is x minus 5 multiplied by log of 4 equals log of 16. And then what do you do? Divide by log of 4, log of 4. And I get that x minus 5 equals log of 16 over log of 4. And how do I get x? I add 5. So x equals log of 16 log of 4 plus 5. When you plug log 16 over log of 4 in your calculator, what do you get?
Two.
2 plus 5.
So you get x equals 2 plus 5, and 2 plus 5 is 7. Boom. Huh? Yeah, it's super.
I feel like this one is so much easier than the previous ones.
Is it?
Mine.
I think it's more straightforward. I do believe. Like the one that we just did, the one with the open box. It's not that it's hard. It's just like
Like to visualize that and like
yeah, it's to visualize it. It's not that you guys can't do it. It's just that
But they didn't put it in the last couple files, right? That's a good.
they haven't done it. I haven't seen it. So I know it may be a little stressful to try to know everything at the same time. But you gotta know at least the fundamentals. What's gonna be there 100%? Difference quotient. You gotta know solving equations, right? We've done this. Logarithmic equations, exponential equations. You gotta know trig, how to solve trig. You gotta know how to prove identities. Like those things you have to make sure you know. Polynomials, how to graph polynomials, all these things again. Transformations of functions.
I have a question, like I just want you to confirm it.
Yeah.
9b, right? 9a and b. We're gonna find the unit price that we yield maximum revenue. So you're gonna do negative b over 2a, and then you get that answer, and then you're gonna plug it into the equation for b, correct?
Yeah, so the negative b over 2a would be part A.
Yes.
That would be unit price, and then what's the revenue? You plug that in to your function to get to the revenue, which would be y value.
Okay, thank you.
So anything else? Yeah.
A lot of times on these finals, they ask you to like sketch the graphs. Like, how do we do it on the test? What do you give us like a graph? Or we have to just like draw it out because it's so
See,
confusing.
it's not my final. If it was my final, I'll give you
Do they
everything.
do that like in previous years?
And what?
Like, do they give you a
I'll
graph?
give you nothing.
What? They just give you.
So you got about
You see, you guys have been treated good in my class. I give you graphs with nice little sketches, and you have to be, oh, I have a point here, I have a point here.
Yeah, that's what we always do.
Yeah, no. They just give you a blue book. Your blue book. Boom, do it.
So how do you grade it?
What do you mean how do I grade? I grade what you give me.
So how are you supposed to know like this is coordinate 1 and 1?
You have to show me.
Just draw it.
You have to be like draw and okay, this point right here is coordinate, this that and third. This is another coordinate.
So it's like
Yeah,
a rough
tell me.
sketch.
So it's a sketch, it's a rough one, yeah, because
Okay, okay.
you have these lines like this, right?
Yeah,
How
yeah,
are you gonna do that? You're gonna be like this
Yeah,
and
that's
then
what I'm saying. Can you
you
bring
guys
graph
good, right?
paper?
Huh?
Can you bring graph paper? Like,
yeah.
I would just be so
I don't-
confused, like drawing.
Yeah, I know. See, you know what? Maybe I shouldn't have given you the graph paper. Maybe I can't do it.
So go to the board and be like, did you graph
You are
it?
so testing.
Wait, what?
But
Because
the test, exam number 3, I haven't fully finished grading. Yeah.
Like actual, it's like a word bomb, it's like a long
Oh, he loves
one.
that.
Should I read it or?
Let me see. Holy smokes, I'm ready for anything. anything and everything. So this is what, fall 2013? This is the last question, number 11. And it says a married couple is given by the function h of t. So what's h of t here? When you see this, you should have a sign of relief. Oh, great. Why? Why should you have a sign of relief? What type of function is this? Quadratic. We love quadratics, right? We should love them. These are easy functions to deal with. We know what we've seen them. We know how to solve for the maximum, the minimum. We know how to find the roots. Like they should be like, oh, thank you. Oh, how do you? So that's the function that we have. And what are we trying to find? What are we trying to do? And that has like several parts to it. So h of t represents the happiness. This is the happiness function. Of course, you have to make it something like this is the happiness function of a married couple. Of course, this is not real life because I don't think the happiness of a couple is measured by that function. But I guess you have a pretty good sense of humor here. So where t is measured, t is measured in the marriage. T is years. Oh, okay, I see what you're going to do. In years from the beginning of the marriage. Wow, somebody has a pretty interesting view of marriage. So. It says, how happy is the couple at the beginning? Kind of weird. And so it says the units are in units of cotton candy. That makes no sense. The units of cotton candy. Yeah, this person, whoever created it, had a very maybe they just got married. Had a couple of drinks. So T represents the years of the marriage from the beginning, and the output is the units of cotton candy. I don't know what that means, really. And then it says part A. Let's see if you guys are laughing, so this is good. How happy is a couple in the beginning? So how happy is couple in the beginning? So this should be an easy question, right? How do you find the happiness of this couple in the beginning? The beginning is when t equals what? 0. So what do? Plug in 0. H of 0. What's h of 0? You do 5 times 0 minus 0 squared plus 6. What's 5 times 0? 0. 0 minus 0 squared? 0. 0 plus 6 is 6. So there were 6 units of cotton candy happy. I don't know what's wrong with that. I don't know what that means. So this is 6 units of cotton candy. That's how happy they were. They had 6 units of cotton candy. You guys like cotton candy?
Yeah.
Sorry. Okay, I'll tell you that.
I'll just roll through get couples counseling.
Huh?
Get couples counseling.
Yeah, you got cotton candy. Cotton candy. Okay, so now it says part B. When does the happiness in the marriage hit rock bottom? Ouch. Wow, that went fast. How happy are you? When does happiness hit rock bottom? And what they mean by rock bottom is that H equals 0. So when do they have 0 units of cotton candy? So then what do you do here? It's a good question, yeah. You want the output to be 0. Huh? So you set it equal to 0. So you said 5t minus t squared plus 6, you said equal to 0. And what are you trying to solve for? Remember, it says when. So you're trying to solve for t. You're trying to find what's the time when the marriage hit rock bottom, which is kind of sad.
You have to rearrange it.
I can rearrange it. Very good. So this is negative t squared plus 5t plus 6 equals 0. Oh, okay. And then what you could do, remember this negative here? You can multiply everything by -1. And you get t squared minus 5t minus 6 equals 0. The reason why we do that is because to factor it, we usually have a positive number in front. And if we multiply everything by -1, we don't change the actual solutions. We just change the quadratic function. But the solutions are left unchanged. Now can we factor this? Yeah. How do you factor this?
That'd be t minus 3 and t minus. Yes.
T minus 6 and t plus 1, right? It's not minus 3 minus 2.
Oh yeah.
Why? Because
Oh,
minus
because
3
one.
times negative 2 is positive 6. This is minus. So it has to be a minus 6, positive 1, because when you add these, you get negative 5. When you multiply them, you get negative 6. So then t equals what? T plus 1 equals 0. So t equals what? Negative 1, and you get t equals 6. But which one of these are we going to use? 6. Why? Because we're starting from 0. We don't consider what happened before they got married. Okay, after they got married. So after 6 years, things hit rock bottom. Or at 6 years. Marriage, huh? Not easy, not easy.
After 6 years.
I went to a wedding recently. They were happy as could be. Hopefully it lasts.
Was there cotton candy?
Cotton candy. There was a lot of, there was a curry chicken, jasmine rice.
Also an Indian one.
A little bit, yeah. Yeah, it had a little Indian flavor to it, definitely. So how many years into marriage is a couple happiest? Oh, this is a good question. How many years into marriage is the couple happiest? So what are we gonna find here?
Can you just rough it?
Deferred text, thank you very much.
It just like
Can
popped up to me.
Of course, it can help you, right? Whatever helps you. But I'm just asking, what are you trying to find?
Oh, okay.
Vertex. Find vertex. Because this is what? This is a quadratic function, right? And remember when you rearranged it, you have this negative here. So it's going to be a maximum. It's going to be a maximum. So if you graph it, what happens when you graph it? T0, right? This is 6. It's going to look something like this, right? Something like this. Now the question is, when does it hit rock bottom? Remember when it hits rock bottom? At negative 1 and at 6. So there's going to be a point here where it's happiest. How do you find this point? You get to the minus b over 2a. So t is going to be what? Negative b over 2a. Now, if I take this function again and I rearrange it, put the t squared first, I get negative t squared plus 5t plus 6. So be careful with this. The reason why they did this is to trick you. Because they know they're going to be like, oh, the first number, that has to be a. It's not a. What's a really? A is the coefficient in front of the squared term. So here, the squared term has a negative 1 as a. What's b? 5c is 6. So what do I do here? Plug in. Negative 5 over 2 times negative 1. 2 times negative 1 is negative 2, so I get negative 5 divided by negative 2, positive, so t is 5 halves or 2.5 years. So in 2.5 years, the marriage is happiest, according to this.
Are there more? Is that the last part?
Oh,
That's
Wait,
more.
what?
Oh, you can also use maximum, yes. How do you use it? You do a second trace. You have the maximum. So you can also use your calculator to see how do you find the maximum. Use the max function and you find the 2 points left and right, make a guess, and you get 2.5 comma whatever you get for this, right? And then part D. This part D might be a little depressing. It says, what happens, who did it? What happens to the happiness of the couple, wow, as the years go by, as time goes by. So, according to the function, as time goes by, my happiness just goes what?
Yeah.
Huh?
So that's the answer.
Sorry. Yeah.
I wish that question was on you. I wish.
Yeah, that's what happens. I think it's a stupid question. Not even,
You probably fired him.
you know,
Yeah, now they made it all blend.
thank you.
So I chose this question.
Yeah, but don't
What is this question?
yeah, forget about the cotton candy happiness, whatever, right? What's really important is, do you understand how to get information from quadratic functions? Do you know how to set it equal to 0? Do you know how to solve? Do you know how to interpret the maximum min? Like, do you know how to do that? Good. If you can do that, then talk about happiness in the marriage or maths. You should be able to take care of it. Yeah.
From our end, we set plug 0 in, like it says in the beginning.
Yeah.
Why
So,
wouldn't you plug the end? You just have to.
because the beginning, when you talk about modeling questions, right? When you model whatever it is that you model, whether it be happiness, whether it be trajectory of a goal, right? When you model it, you start at the beginning. Right? At the beginning of time, t is 0.
So they give you that, or you don't?
No, you have to. Here they gave it to you, but normally they don't give it to you. Normally you have to know. When you model something, there's a certain time that's the beginning, right? We call that time 0. What is it gonna call it? 1? But then like you go behind 1, yeah, you go 1.5, right? We technically don't normally don't use negative numbers to represent time. This doesn't make sense. Physically.
You do an equation where you graph cosine or sine, either one.
Let's see.
Yeah.
So this is fall, same year, 2018. Oh, 2018. Not same. This is part of 8, number 8. This is number part B. So this is when you have a cosine curve and you want to graph it on the interval 0 to 2 pi. And you want to sketch it. You want to label all the vertices, intercepts, equations, the asymptotes, everything. So try to be as detailed as possible. So this is what I have. I have a sinusoidal function. So what do we know about sinusoidal functions? We know we can figure out what the amplitude is, right? What's the amplitude here? Remember, it's the number in front of cosine. There's no number here, so you assume it's going to be 1. So we know that the amplitude of the wave goes up 1, goes down, goes up 1, goes down. Okay, good. What else can we find? You can find the period. How do you find the period?
Pi over frequency.
Yeah, so 2 pi over the frequency. And what's the frequency here? The frequency is 9/2. So then when you divide the 2, you get 9. So what does that mean? That means that after every pi unit, you see 1 full cosine curve. That's what the period tells you. It tells you how long it takes to see 1 full curve. And this curve is cosine. What else can you say? What's the midline? The midline is not 1. The midline is y equals 1. A lot of people did this. They just put 1. No. The midline is a line. So you have to give the equation of the line, not the value of the line. So the midline is y equals 1. It's the equation y equals 1. So I got the amplitude, I got the period, and I got the midline. So that gives me a lot of information so that I can graph it. So when I graph this, I want to go from 0 to 2 pi first of all, right? So I'm going to go from 0 to 2 pi. This will be pi, and this will be 2 pi. But what do I know? I know I see 1 full curve every pi units. So I'm going to have 2 cosine curves between 0 to 2 pi. Because for every pi units, I see 1. I know that my midline is at 1, so that means that I have to, my center of this curve is at 1. I know that my amplitude goes up 1. So then my max here will be 2, and my min will be 0. Remember, what's my domain? My domain is -infinity to infinity. And what's my range? How do you find the range? I go from my midline and I add by the amplitude. Take my midline, subtract by the amplitude. So I get 0, 2. So my range goes from 0 to 2. Now the last thing I have to do is what? I I take my period and I divide it into fourths. So this will be pi over 4. This will be pi over 2. This will be 3 pi over 4. This will be 3 pi over 2. This is 5 pi over 4. This is 7 pi over 4. Now, why do I do that? Why do I divide the period into fourths? Because if you look at the cosine curve, in just a regular cosine curve, right? I know it looks like this. From 0 to 2 pi. There's a symmetry, right? This is pi, this point here is pi over 2, and this is 3 pi over 2. These are fourths of the whole. This is a fourth, a fourth, a fourth, a fourth of the entire period. So every single time you find the period, I have to divide it into fourths. And I did that. Now I'm going to take this exact same cosine curve and just put it on here. But see, this cosine curve starts from 1 to -1, right? But this cosine curve goes from 2. And now my midline here is 0, but my midline here is 1. So in the next fourth of the way to the period, I'm at the midline. And then when I'm at halfway, I'm at my lowest point. So halfway between the period here, I'm at my lowest point here at 0. Then I come back to the midline, then I come back to the highest point. So I have something that looks like this. That's one period of my cosine curve. Because my cosine curve starts from the top, goes to the bottom, comes back to the top. That's cosine.
Why is the bottom not at pi and it's at
This one? Well, first of all, the period is no longer 2 pi, it's pi.
oh, so you're just making it
So I'm making it shorter, right? The period has shrunk. So now this is what I'm looking at. And I'm dividing the pi into fourths.
So the middle is pi over 2.
So the middle is pi over 2. And now this will be my minimum point. Now come back here. Now I repeat the same thing. This will be go here, this will go here, this will go here, this will go right here. So now I have two cosine curves in 2 pi units. Because I have my period is pi, so I see for every pi units, I see one full cosine curve. So in 2 pi units, I see 2 of them.
On a test, really only one curve or the whole?
Well, it says here on 0 to 2 pi. So it depends upon what the interval is. Most likely, it's going to be 0 to 2.
Yep, and then cosine if it was sine, it just starts.
If
at
it's
0.
sine, it'll start here. And then you
Okay.
have the cosine curve. Sine curve. So you always have to go back to the basics. Always go back to the parent function. Understand that well, and then you can translate it, transform it. Yeah.
F goes into Fx. Does that mean it's like the same thing?
That goes into what?
1b.
Oh, f of f. Well, that's a good question. Okay, that's a good one. Yeah, that's the one I was talking about earlier. So what year is that? 2018. So this is spring, right? Yeah, this is spring. 2018. This is number 1, right? You have a function that has 3 over x, right? Very similar to the one we did 1 over x. This is 3 over x. And part B asks f of x. What does this equal? And find domain, right? So first of all, this is what's called this is called a composition of what? A function. So this means that f is inside of f. You're plugging in f into f. So your f of x is what? 3 over x?
Yeah.
And you're plugging 3 over x into itself. So what's going to happen after you do that?
3 over x.
I'm going to have 3 over 3 over x, right? But then, when you simplify 3 over 3 over x, what happens when you divide by a fraction? Multiply by reciprocal. So I get 3 multiplied by x over 3, right? What happens with 3 here? You cancel that, left with what? So f following f equals x.
Is this always the case?
No, it's not. No. Just so happens to be this case here. So it's x. But this is not that straightforward. What's the domain? -1, right there. It's left. A lot of people don't do that. -1. Why? So the final answer, you get x, right? So you're thinking, oh, I can plug in any x value in here. That will work. Not every x value works. Go back to the beginning. What doesn't work here? 0. Why not? 3 divided by 0 is undefined. So x doesn't work. So x wouldn't work here. The moment I plug in x here, fails. 3 divided by 0, 0. That is undefined. So x cannot equal 0. Because the very essence of this function here, x cannot be 0. So what's my domain? It's not negative infinity to infinity, it's negative infinity to 0, union 0 to infinity. I excluded 0. That's the only thing I exclude. Everything else is okay. Good? Good or not good?
Are you taking more questions or?
Yeah, I think a few more. I came a little late anyway, so I a little late, so.
Can we go over time?
Number 9?
Yeah, no, not in this one.
So what? Okay.
This one pops
It's cool stuff. Okay, so what is this? What year is this?
Right.
Spring of what year?
2018.
Oh, okay. Spring 2018. This is number 9. So this just says cosine of A equals -4/5. A is in quadrant 3. Sine of B is -5/13. And B is in quadrant 4. So you have two things here. You have this piece of information, cosine, and you have this piece of information of another angle B. It says evaluate the following. So evaluate the following. So A is cosine of twice the angle. Oh. So this is a double angle formula. And do you know the double angle formulas? Yes, you should know. So what's the double angle formula for cosine?
2 cosine squared
2 cosine squared, yeah.
plus sine.
Cosine of 2a is equal to cosine squared a minus sine squared a. That's one of them. The other one is 1 minus 2 sine squared a. The other one is 2 cosine squared a minus 1. There's 3. Remember, there's 3 versions of cosine. There's only one version for sine. Sine of twice the angle is just twice sine of the angle. Cosine of the angle. Yeah. So here I want to figure out cosine of twice the angle, right? So I have 3 of them to choose from. Which of these 3 is better to choose? The first one? This is a better one. Why is there a better one? Because cosine of A is -4/5, right? Forget about sine of B. This is a different angle. The only information that I have about the angle A is that cosine of that angle is -4/5, and that A is in the third quadrant.
Oh, it's not.
So which one of these only deals with cosine? Third one. So it would make more sense to use the third one. So here I have 2 cosine squared of A minus 1. 2 times cosine A is -4/5 squared minus 1. then from here it's just multiplying fractions. Negative 4/5 squared is 16 over 25. Multiply by 2 minus 1, right? When you multiply 2 by 16 over 25, I get 32 over 25 minus 1. And how do you subtract fractions? You make the same denominators. So 32 over 25 minus 25 over 25 is 7 over 25. So my answer for cosine of twice the angle is 7 over 25. Part B says sine of A minus B. This is a difference formula of sine. You gotta know the difference formula. What's the difference formula for sine of A minus B?
Sine A times cosine B.
Yeah, sine A cosine B minus. For sine is minus, for cosine that's when you flip. So remember that sine you keep the same sign.
Cosine
And then we cosine of A sine B. But the nice thing of this is you know sine A, you know cosine B. So all you have to do is plug in. Well, actually you don't know everything, but you do know. What do you know? You know cosine of A, right? I know this is negative 4/5. What else do I know? Sine of B. Sine of B is negative 5 over 13. But how do you find sine of A? If I know cosine of A. Draw a triangle. I know the triangle has A, right? And I know the opposite side. Well, I know the adjacent side is what? 4. Hypotenuse is 5. But wait a minute. This is 4, 3. So what's sine of A? 3 over 5, isn't it? But I'm in the what quadrant? So then sine has to be? Boom, I got that. So this is negative 3/5. But then what's cosine of B? Different angle, so different triangle. So use the triangle again. Sine here is going to be opposite. 5 is hypotenuse is 13, but wait a minute. 5 what? 13. 12. Oh, good. So then what's cosine of B? 12 over 13, but I'm in the fourth quadrant. Is cosine positive or negative in the fourth quadrant? That's it. So cosine here is going to be 12 over 13. And then negative 3 times 12 is negative 36. 5 times 13 is 65. This is going to be negative. The negative is a positive. Minus is going to be minus 20 over 65. Subtract and you get negative 56 over 65. So we got A, we got B. And what's C? C is secant of B. Oh, this is the easy money, right? What's secant again? 1 over cosine. What's cosine B? So I have really, this is the easiest one of these. So 1 over 12 over 13 is? Done. That's the last one, huh?
Just leave it 1 over 12 over 15.
It's not complete. Simplify. Oh, simplify. 1 over 12 over 13 is 13 over 12. Now the last one is tangent of twice the angle. This is where people freeze up. They're like, oh no, I don't know the tangent formula.
Sine squared.
Its tangent is sine, not sine squared, sine of twice the angle divided by cosine of twice the angle. So didn't we find one of these guys? No, we didn't. Let's find it. So what's sine of twice the angle? It's going to be 2 sine of the angle, cosine of the angle, right? But don't I know this stuff already? I know sine of B. Negative 5/13. I know cosine of B. So 13 times 13 is 169. Negative 5 times 12 is negative 60 times 2 is negative 120. So sine of twice the angle is negative 120 over 169. But then I need to figure out what cosine of twice the angle is. So how do you find cosine of twice the angle?
Wait, I'm confused.
Huh?
I'm confused.
About what?
This is 30.
Say it again.
How'd you have sine two?
I use twice the double angle formula. Sine of twice the angle is 2 times sine of the angle times cosine of the angle. Right? But then I figure out what sine of the angle was. Alright, well they gave it to me. And then don't I know what cosine of the angle of B is? Yeah, 12 over 13. So then I just put them together, multiply, and I get negative 120 over 169. And now I have to find what cosine of twice the angle is. But I have 3 of these formulas. You can choose either one of these. Because I know both of these, huh?
How much is 2 sine squared?
You want to do cosine squared?
No, the sine squared.
Second one? Okay, so this is 1 minus 2 sine squared of B. So what's sine of B? Negative 5 over 13. So I get 1 minus 2 negative 5 over 13 squared. What happens when I square this? Negative squared is a positive, 5 squared is 25, 13 squared is 169, and I double it, and I subtract by 1. When I double this, this becomes 50 over 169, 1 minus that. When you subtract 1 minus this, it have the same denominator, so this is really 169 over 169. And when you divide 169 minus 50, I get 119 over 169. That's cosine of twice the angle, and this will be 119 over 169.
I realized we should just, like, 169 is the hypotenuse and 120 is the opposite. We should just do the diagonal theorem, and I still got 119 for the diagonal theorem. 7 point doing that.
Wow, very good. You can do that.
Yeah, just think that works a little bit.
That works because they're using this angle here. So you can be like, yeah, I have a triangle where one of the angles is twice the angle, and then you say, oh, one side is 120, and you get 119. So you found another Pythagorean triple. Congratulations! I didn't know that. Yeah, you found this. I didn't know this would be Pythagorean triple. So now this will be. Now how do you complete this though? You have this divided by that. Divided by a fraction, you flip the reciprocal, right? So this becomes negative 120 over 169, multiplied by 169 over 119, right? The 169 cancel and I get negative 120 over 119. This is my final answer. So for this guy, I needed to do quite a number of things. I need to first figure out what sine of twice the angle was, but this is pretty straightforward because I already have that. And now cosine of twice the angle, I need to use one of the formulas. Any one of them would have worked because I have sine and cosine. Plugged it in here. And then I divide the two fractions, and I get negative 121. So any questions about this? This is a typical problem. This is pretty straightforward. Double angle. A lot of double angle and difference formulas. And you should be able to be comfortable in creating the right triangle and finding the other side so that it can help you find the rest of the trig ratios. Alrighty? So we've done an hour and 59 minutes of straight precalculus. That's pretty impressive. That's a lot. Alrighty, guys? Great.